For the second part of section 1.6, we are going to review the Pythagorean Theorem. And two parts of a triangle that you need to know are legs and hypotenuse. And if we have a right triangle, we have a 90-degree angle in that triangle. And the legs are the two sides that form the right angle. So this would be a leg and this would be a leg because they come together to make that 90-degree angle. The hypotenuse is the side across from the right angle, and it's also the longest side of the triangle. So across from the right angle would be here, so this is your hypotenuse. All right, so for the Pythagorean theorem, and remember this only works for right triangles, the theorem says that a squared plus b squared equals c squared. A and b are legs, and c is your hypotenuse. So for all of the questions today, we are going to use that particular formula. So example 1 says to find the missing side of the triangle. So looking at this, the right angle would be right here. So that means we know a leg and the other leg because they form the right angle. So we are going to do a squared plus b squared equals c squared. A and b are 6 and 8. It doesn't matter which one is a or which one's b. So we have 6 squared plus 8 squared equals c squared. 6 squared would be 36, and 8 squared would be 64, and that equals c squared. Add those two together, we get 100. And our last step in all of these questions is to get rid of the squared. And the opposite of squaring something is to take the square root of it. So the square root of 100 is 10, and the square root of c squared would just be c. So the hypotenuse of this triangle is 10 inches. For part B, notice the right angle is down here. We're given the length of this leg. We're not given the other leg. We're given the actual hypotenuse. So in our formula of a squared plus b squared equals c squared, we know one of the legs. So we either know a or b. It doesn't matter which one. So we know that's 9 squared. So we don't know what the b squared is, but we do know that c squared, or c, is 15. So we plug it in like that. Then we go through and simplify. So 9 squared is 81. And 15 squared is 225. We're going to have to subtract 81 from both sides. So we would have b squared equals 225 minus 81 is 144. And then our last step is to get rid of that squared because we really want to know what b is. So square root of both sides. So b over here, square root of 144 would be 12. So the other leg to this triangle would be 12 centimeters. For example 2, it says use the distance formula and the Pythagorean theorem to find the distance to the nearest tenth from A to B. So if we use the distance formula, we are going to use the 2 points. A is -2, 3, and B is 2, -2. And the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So if we fill in what we know, we have x from our second point would be out of point B, so that would be 2, minus x from our first point would be -2 squared, plus y from our second point would be -2, minus the y from our first point would be 3 squared. So now we have to simplify what's under the radical here. 2 minus negative 2 is 2 plus 2, which is 4. 4 squared is 16. And then negative 2 minus 3 is negative 5, and negative 5 squared is 25. And then 16 plus 25 is 41. And we're going to leave it right there for a second while we go and do the Pythagorean theorem. And then if we need to simplify it any farther and round it, if I look back in the directions, it says round to the nearest tenth. So I do have to simplify that. So if I type that in the calculator, I get approximately 6.4. Now they're asking us to use the Pythagorean theorem to do the same thing, to figure out what that length from A to B is. So if you have a picture, you can actually construct a right triangle using that line given. And if you look at that, that forms a right triangle, and we are actually trying to find the length of the hypotenuse. So we are going to use the formula a squared plus b squared equals c squared. And the length of A would be going across the bottom there, and it looks like it's 1, 2, 3, 4. So we would have 4 squared. And they have labeled B going up the side, so that would be 1, 2, 3, 4, 5. So that would be 5 squared is going to give us our c squared. So that would be 16 plus 25. And 16 plus 25 is 41. And our last step in all Pythagorean theorem problems is always to cancel that squared. So we have to take the square root. So c equals the square root of 41. And we know that that is approximately 6.4. So now we have two different ways to figure out the distance of a segment if there's a picture, or if you want to take the time and actually draw it out and plot the points. You can use the Pythagorean theorem. So example 3 says to use the distance formula and the Pythagorean theorem to find the distance to the nearest tenth from R, which is 3, 2, and S, which is negative 3, negative 1. So the distance formula first, remember, is the square root of x2 minus x1 squared plus y2 minus y1 squared. So x from my second point would be negative 1. Nope, it would not. It would be negative 3. Minus x from my first point would be 3. Y from my second point is negative 1, and y from my first point is 2. And then simplify the parentheses. Negative 3 minus 3 is negative 6. Negative 6 squared is 36. And then negative 1 minus 2 is negative 3. Negative 3 squared is 9. If I add those two together, I get 45. The root of 45 is approximately 6.7. Now to use the Pythagorean theorem, we don't have a picture, so we're going to have to take some time here to draw it. And point R is 3, 2, so over 3 and up 2. So that's going to be R. And S is negative 3, negative 1. So there's our S. If we connect those, we need to find that distance. So I'm going to have to make a right triangle. And I could have went up and over as well. It doesn't matter. The lengths are going to be the same. Okay. So it looks like I was up 2 here at R, and I had to go down to negative 1. So that would be 1, 2, 3. And then at S, I have to go 1, 2, 3, 4, 5, 6. So S would be 6. And then we plug all of our information into the Pythagorean theorem, which is a squared plus b squared equals c squared. And our legs are 3 and 6, so 3 squared plus 6 squared equals our c squared. So 9 plus 36 equals c squared. 9 plus 36 is 45. And then we have to undo the squared. So we have to do the square root. So c equals the square root of 45 exactly. And then if you type that in your calculator, you're going to get about 6.7 if you round to the nearest tenth. So both formulas show us the exact same distance for the segment of SR. And for our last example here, the 4 bases on a baseball field form a square with 90-foot sides. When a player throws the ball from home plate to second base, what is the distance of the throw to the nearest tenth? So looking at this picture, what they're really asking us to find is the distance from home plate to second base, which they drew the line for. And when they draw that line, it actually forms this right triangle. And I'm going to look at this one. There is one on the other side that you could use as well that has the exact same dimensions. So here's our right angle down here in the corner. From first to second base is 90 feet. They told us that in the directions. And if you look at our y-coordinate, we're at 0. And our y-coordinate at second base is 90. So we went from 0 to 90. So we went up 90. And then from home plate to first base, we were at 0 for home for the x. And our first base x coordinate is 90. So we went from 0 to 90. So that length would be 90 as well. Now, all it's asking us is what is the distance of the throw to the nearest tenth? So we could use one of two things. We could use the distance formula or we could use the Pythagorean theorem. And since this section is focusing more on the Pythagorean theorem, that's the one I'm going to use. So a squared plus b squared equals c squared. Now, you're not going to be wrong if you picked the distance formula. If that makes more sense to you, absolutely go ahead and use it. So our legs that form the 90-degree angle are both 90. So 90 squared plus 90 squared is going to give us c squared. And 90 squared, 9 times 9 is 81. And then 90 times 90 would have 2 zeros. So they're 8,100 for both of those. And if I add those together, I get 16,200. And our last step would be to take the square root of both sides. And the square root of 16,200 is roughly, so I shouldn't put an equal sign there because we're going to have to estimate, and the direction said to the nearest tenth. It's about 127.3, and this is all in feet. So if you were throwing from home to second base, you would have to throw the ball 127.3 feet.